All right, so I just want to take a second to introduce the egg drop engineering competition. Um, so maybe you've done something like this before. There are some different rules for ours to make it a little bit more like engineering competition. So let's take a look. It says engineering goal at the top here. You will build an egg drop device that prevents your egg from cracking when dropped from a height of about 26.6 feet. And then that's the height we usually use. It can vary depending on where we drop it from, depending on how nice it is outside and where we're dropping, but it's going to drop from a really high height, close to 30 feet. It says the winning device will be chosen based on its ability to keep the egg safe, no cracks, and was built for the lowest cost. Along with the pride of being deemed class champion, you'll also receive a little extra credit. Extra credit is awarded only if your egg drop device is built for the lowest cost in your class. So, a couple building restrictions. Number one, your device must be built in class during the allotted time. If you need additional time, you must come in before or after school. And that's just to make sure you're building it. So it's your ideas, you're taking the time to build it, and nobody from the outside is helping you. So, number two, you may only use the supplies listed below or introduced in class. Number three, you must be able to easily add or remove your egg from your device. So basically, kind of picture it like an automobile. The passenger should be able to get in and out. You can't make it so that your egg cannot be extracted from your device, because then how could we ever check it to see if it cracked? So you should be able to put your egg in, and maybe you're buckling it in or putting like a little like seatbelt on it. That's fine, but it should be easy to add and remove the egg. Number four, you must stay below your engineering budget. So you're going to have $35,000 of fake money to buy supplies here coming up. We'll go through that. Number five, when gluing, you will use Elmer's glue for the majority of construction. When gluing the plastic straws, you may use hot glue or simply tape them. And that's if we have hot glue. Sometimes we don't use the hot glue because it gets pretty messy to use hot glue. But however, hot glue cannot be used in excessive amounts. If gluing two straws together, there should be enough glue to keep the straws bonded. The glue should not be visible or minimally visible, so just enough to get the things connected. You'll receive one glue warning and then be fined $10,000 for excessive glue usage. And I've only ever had to do that one time, maybe twice in my teaching career, because a student was trying to put too much glue on it to hold everything together at a ridiculous strength level. So don't abuse the glue. Number six, each person must build their own device, but it is fine if you discuss blueprints, ideas, and work with others. Just remember they are your competitors, because you're trying to make yours survive for the lowest cost. So if you share an idea with somebody and they take your idea and make it better, then they could potentially beat you. All right, your engineering budget's $35,000. Initial supplies and cost. You can test fit your egg. We have some fake little plastic eggs that I stole from my kiddos, my personal kids. They're free. Just pop in and make sure it fits, and then pop them out. Rubber bands and paper clips are $500 per one. Straws, popsicle sticks, $1,000 per straw. Printer paper is $1,000 per sheet, and max 4 pages. That's initially, because I just don't want everybody to grab paper right out of the way, but eventually we'll get more. You can use more than 4 pages. Kleenex is $1,000 per tissue, and it says max is 6. Cotton ball, $2,000 per cotton ball. Masking tape, $4,000 per foot. Cardstock is kind of that really thick paper. It's $5,000 per page. Bubble wrap, we will have about a 4x4 square you can buy for $5,000 per piece of bubble wrap. And then the Ziploc bag is free, because that's what your egg will go in. And then when we drop it, that way if your egg cracks, the egg guts or the yolk goes inside the bag and not all over your device. So it says this holds the egg so the yolk doesn't leak out. It may not be used for any type of parachutes. That plastic bag that I give you, you can't like rig up a parachute. It's just to hold your egg. Further, there can be no parachutes, wings, streamers, or propellers, because the whole goal behind this project is to see if you can make a device that hits the ground really pretty hard and then survive. All costs are guided by the free market. What does that mean? So supply and demand, people. So basically, just to summarize this paragraph, say that a lot of people are buying a certain supply. I actually might increase the cost of that supply, because if I'm starting to run out, I want to try to make it so less people buy it. So I might some days change the prices a little bit to try to encourage people to buy other supplies, and that's just so I don't run out of supplies for, like, say, my 6th or 7th hour. 5 steps for success. You're going to watch a video shortly. It talks about how to keep people safe in a car, and there's basically 4 different safety features in a car that keep passengers safe. So you're going to watch that one, and then just try to think about, for the research, how that would apply over to an egg drop. And then feel free to Google things as well, but just make sure that when you're Googling stuff, you actually do the research to make sure that the design works. Number two, draw a detailed blueprint to scale. It should include a list and quantity of each of your supplies, and that'll be one of your assignments before you get started. Just sketch out a blueprint and what you think you're going to use, so then that way you can make sure you didn't overspend that $35,000 budget. Number three, in order to make a detailed blueprint, you're going to have to maybe make some measurements of the possible supplies just to make sure that you're measuring and everything's looking like it's lining up and things like that. Number four, you'll estimate the cost of how much it's going to cost to build your device to make sure it's below $35,000, and you're going to put that right onto your blueprint. And then lastly, you're going to start building once you turn in your blueprint. So you can't start building until you turn in your blueprint, just because otherwise I've had people who are like, yeah, I think I know what I want to do, and they buy all the supplies, and then they realize that their idea is not very, or is maybe it's not going to work out, and they want to try to return the supplies. But once all sales are final, once you buy something from the physics store of supplies, you can't return it. So that's why we kind of want to be careful with what we buy. But if you do have a supply that say you're not using and somebody else is like, oh hey, I could really use that, you could trade with other people. Cool, so we'll build in class. At the end of class, you'll have a big Ziploc bag, and you'll put your first name, your last name onto it, and you put all your supplies into that bag, and then we'll seal it up, and then I'll go and hide them away so nobody else will mess with your stuff. But that's an intro to the egg drop engineering competition. Trying to keep an egg safe. You have a budget. You get to design your own device, building it yourself. These are our standard supplies. And then if I have extra supplies of maybe different materials throughout, I might introduce them along the way. So I might have like a few bonus supplies as we build. So if you do have questions, go ahead and reach out to your favorite physics teacher and we'll get them answered. But good luck to all of you. Egg drop engineering competition. That's a little summary.